So far, the data I've been working with has mapped conveniently to screen coordinates. My min and max points are 50 and 150 respectively, so we haven't needed to worry about scaling. Real-world data, however, rarely fits conveniently within a zero-based screen coordinate system. We need scaling functions. Fortunately, D3 has some very convenient scaling functions that will allow us to easily map our data to screen coordinate systems. I want to start by variabilizing the width and height of the drawing surface. I used 600 by 400 last time, so I'll just replace these constants with variables. I'm going to start by scaling the y-axis. I create a linear scale and set the range of my points to be between 0 and the height of my space. Next, I need to set the domain of my data to be the minimum and maximum values. For our data right now, that's 50 and 150. Scale y is a function that I can call with my data, which will properly translate to the screen coordinates. My y function can use it. My height is set to 400 pixels, which seems a bit steep. I'll back it off to 200 pixels and let my scaling function figure out the rest for me. There, that's better. Next, I'll tackle the x-axis. Remember that the x-axis is based on the position in the array. I'll keep it that way, but I'll scale it to fit the space. My range is between 0 and the width. My domain is between 0 and the last index of my data. And I can apply it to the x function and see my scaled results. Now for a little cleanup. First, most graph coordinate systems use a bottom base for the axis. Since screen coordinate systems use a top base, I want to flip it. It's as simple as flipping the order of the range in my scale. Nice. Next, I don't want to use hard-coded values for the min and max of the domain. I can use D3's min and max function. Alternatively, D3 provides an extent function which returns an array of min and max values. My last bit of cleanup is because my extreme data points are being cut off. I'd like to apply a margin to the drawing surface. I'll use 50 pixels. Now, when I create my SVG surface, I will tell it to use the width and height plus the margin times 2 for either side. Next, I want to shift all of my drawing out by the size of my margin. I can do this by creating an SVG group and use a translation transformation on the group. Instead of using hard-coded values, I should use the margin variable. This will become the new SVG variable where everything gets drawn. Now my drawing area is offset a bit and my circles won't get clipped. With my scales in place, I can now change my range and the data will expand and contract to fill it. I can also expand the domain of my y values, or add points, which expands the domain of my x values, and the graph responds correctly. There are different types of scales, and several more features, but that is for a different lesson. In the next lesson, I'll show you how to add axes to the graph.